So now let's talk about parking service. Okay, before going there, what all things will happen? Parking service will obviously have an instance of parking lot, right? That's why it will be able to make changes. Okay, this is one. So we can have parking service. We should have parking lot as a data member to this service. Now, other thing which I can think of is parking lot class should be made singleton again, so that it always return the same instance of the parking lot, right? So that whenever some activity, for example entry or exit, that is happening, it makes changes to the same parking lot. So parking lot should also be singleton class. Great. What will happen in a parking lot? So there would be two activities which I can think of: entry of a vehicle, exit of a vehicle. Okay, let's build it. First would be entry and second would be exit. These would be two activities that would be happening. So what would happen in an entry? First, according to the vehicle and according to the strategy, a parking spot would be allotted to this vehicle, right? And then a parking ticket would be issued, right? That is what would happen. First of all, that status of that parking spot went from free to non-free, because earlier it was free, now it's non-free. Second, change of that parking spot type on the display board would happen. This is the second thing that would happen. So changing display board would happen. Let's talk about exit now. So when exit is happening, first of all, we would validate if the ticket is for the correct vehicle or not, right? So first thing that would happen is validation. Second thing that would happen on an exit is that we would charge them, or payment would happen. So payment would happen. Third thing that I can think of is again the count of free parking spots on display board would change, right? So change on display board. This is the third thing which I think would happen. So I guess this should be good. We can think of entry now. So since entry is on the basis of strategy, and right now we have two strategies, nearest first and farthest first. So what we can do is we can have nearest first entry as the first method. So if the parking lot is using a strategy of nearest first, we'll call this method nearest first entry. What will we get as an argument? We'll get as an argument a vehicle, and what will it return? It will return a parking ticket. Same ways, if the strategy is farthest first, so we'll have farthest first entry, same arguments, and we'll return parking ticket. Okay, both the methods which we have made would change the display board. This is recurrent, and would find the appropriate parking spot, right? Going forward, let's say one more strategy comes in, which says smart strategy. So you will have to make one more method here, which means you will have to update this service, which means it will violate open close principle, right? So don't you think we should optimize it because we are violating open close principle? Yes, we should. So what should be done? Okay, we are again and again using the word strategy here because one recurrent job of updating the display board is happening. Okay, the uncommon work is finding the correct parking spot, and it depends on strategy, which is nearest first and farthest first, which is decided at the runtime. So can't we use strategy design pattern here, right? And both the different strategies can implement finding of parking spots in their own way. What do you think about it, right? So we can use strategy design pattern here. It will help us follow all the solid principles also. So let's say we have an interface strategy, and what do these strategies have to do? Allocate or find parking spot, right? Find parking spot. Okay, so how will on what type of parking spot do we want to find? Let's say if a vehicle arrives in, let's say a bike arrives in, so we want to find mini parking spot. Let's say we pass in here parking spot enum. Now since there are two strategies, so both of them would implement this method. So first is, let's say, nearest first strategy, and second is farthest first strategy. Again, where do they want to find the nearest? In the parking lot. So both of them will have instance of parking lot. So parking lot, both of them will have. So now if we see in parking lot, we have a list of parking spot, right? We have a list of parking spot. So if I have to find the nearest parking spot of type, let's say mini or mini parking spot I want to find. Let's say this is my list of parking spots. This is one object, this is second object, this is third object, fourth object, fifth object. Each of them are different parking spots, right? One could be mini, one could be compact, other two could be large, right? So how will you be able to find the nearest parking spot? By iterating on this complete array, right? Yes. So which would take order of n time complexity, right? Which would be pretty bad, right? Can we optimize this? Can we optimize it here? First of all the parking spots are present in the same list. What if we segregate parking spots on the basis of type? So for example, if we have created mini parking spot, let's have a separate list of compact and separate list of large. This should be pretty much good, right? So we are already getting an enum, right, of parking spot. So what if we create a map with key as spot, parking spot enum, and value as the list of those parking spots? This would reduce our time, right? Because earlier in this list, there were all different types of parking spots. Now, the worst case time complexity is reduced from order of n to order of n by 3, right? Okay, great. Which is again, if we see, this is order of n only, worst case time complexity. This is order of n only. Can we optimize it further? Okay, this had made our structure more, this has made storing parking spots in a more structured way. Yes, we agree. Okay, what if we store all the parking spots in the list in a sorted format? Don't you think that would be better? Because if I want to find the nearest first parking spot, so nearest first parking spot would always be present at the first in the list, and the farthest first parking spot would be present at the last index. So which would make things finding the parking spot order of one. Why? Because if I want mini parking spot, I'll go on my map, I'll find mini, I'll get this list, and if I want nearest, so I just want to return first parking spot, and if I want farthest, I want to return last, right? So we'll make it a point that whenever we have, we'll keep this list sorted on the basis of floor number and ID. Okay, great. So now since we are not having list of parking spots, we are having a map of parking spot. So let's update the data member. We have map of parking spot enum and list of parking spot. Okay, great.